On January 4th, 2026, Milvus v2.6.8 was released, boasting a Python SDK version of 2.6.6, but strangely, its Java SDK was already at 2.6.11. AI moves fast. Here's what matters. This is AI Daily for January 4th, 2026. Today, Milvus.2.6.8, the 3.6.0 beta.2, B7622, plus our deep dive into Milvus.2.6.8. Let's go.
Here's your AI Daily News Roundup for January 4th, 2026. All right, folks, let's dive right into what's happening in the world of AI. Kicking things off, Milvus, the open-source vector database, just dropped version 2.6.8. Now, why should you care? Well, this release includes search result highlighting. Think about it. When you're dealing with massive datasets of embeddings, quickly identifying the relevant parts of your search results is crucial. It saves time, reduces cognitive load, and lets you iterate faster. They've also done some under-the-hood optimizations for query processing and resource scheduling, which translates to faster and more stable vector searches. For anyone working with large-scale AI applications, this is definitely worth a look. Moving on to the front-end side of things, Vue.js released a new beta, version 3.6.0 Beta 2. Beta releases are important for software engineers because they offer a sneak peek at upcoming features and improvements. While it might not be ready for production environments, testing it out can help you prepare your code bases for future updates and identify potential compatibility issues early on. Plus, providing feedback during the beta phase can directly influence the final product. So if you're a Vue.js developer, this beta is your chance to get involved and help shape the future of the framework. Also making waves today, Llama.cpp, the popular library for running large language models on various hardware, has been churning out a lot of updates. We've got a flurry of releases: B7622, B7621, B7620, B7619, and B7618, all hitting in the last 24 hours. Now, I know what you're thinking. 5 releases in one day? What's going on? These are largely bug fixes and performance improvements targeted at specific hardware and configurations. For example, some are CUDA-specific fixes, addressing things like concurrent streams and memory allocation. Others tackle issues related to token padding and graph reuse. Why is this crucial? Because Llama.cpp is all about democratizing access to LLMs by making them run efficiently on commodity hardware. These rapid-fire releases demonstrate the community's commitment to squeezing every last ounce of performance out of these models. If you're running LLMs locally, especially on GPUs, keeping an eye on these releases and updating frequently can make a noticeable difference in speed and stability. It's like getting free performance upgrades. In other news related to Llama.cpp, release B7618 specifically addresses a bug fix related to pool allocation counts in CUDA. Why is this worth your time? Memory management is crucial to performance, especially when working with large models on constrained hardware. This fix prevents situations where incorrect memory sizes are computed, which leads to allocation errors or crashes. For AI practitioners, especially when working with CUDA, this is a good reminder of how the smallest details can make all the difference in ensuring stable and performant AI applications. And that's release B7619, which specifically addresses that CUDA memory usage, where the temporary buffer for flash attention is only allocated when it is needed. This means less memory consumption and potentially allows for larger models to be run with the same hardware. That's the news for today. Now let's dive into our deep dive topic, comparing the performance of Llama 3 small versus medium-sized models for edge deployment. You know, I saw the Milvus 2.6.8 release pop up, and I almost just scrolled past it. A point .8 release landing on January 4th, 2026? It just screams minor bug fixes, Happy New Year. But there's a feature in here that seems almost comically simple on the surface, But the more I think about it, the more I realize it's actually a huge user experience deal.
Let me guess, you're talking about the search highlighter.
Exactly. Search result highlighting. It feels like something out of 1998. It's grep with a yellow background. Why is this a headline feature for a cutting-edge vector database in 2026?
Because it's not just about finding a keyword. In the context of RAG and hybrid search, it's about explainability. When you get a result back from Milvus, especially from a hybrid search, you have two signals: the vector similarity score from your embeddings and the keyword score from something like BM25. The user doesn't know why that document was surfaced.
Okay, so this isn't just a simple string match on the return text. It's highlighting the specific terms that contributed to the BM25 part of the retrieval score.
Precisely. It connects the what with the why. If a user asks a complex question and gets a paragraph back, the vector similarity might have gotten it in the right ballpark, but the highlighter can instantly draw their eye to, oh, it pulled this because it contains the exact phrase in-memory data grid that I used. It makes the system feel less like a black box.
And it's not just for the end user, right? For a developer debugging a RAG pipeline, this is gold. You can immediately see if your keyword search is pulling its weight or if it's all just vector similarity. I see they fixed a bug where it failed with multiple analyzers, which hints that people are already using this with complex text processing pipelines.
Yeah, and it even works for non-BM25 searches now, according to one of the bug fixes. The implementation detail that's interesting is where this computation happens. It has to happen after the search results are compiled, but before they're sent back to the client. It adds a bit of latency, but the value is immense. For any application that's showing retrieved context to a human, this is a non-negotiable feature now.
Right. It moves from a nice to have to a core part of the retrieval experience. But okay, digging past the highlighter, the real story of this release seems to be the plumbing. I'm seeing a laundry list of performance and stability improvements. The one that really stands out is moving query optimization logic to the proxy. That sounds significant.
Oh, it's a huge architectural shift. Think about how Milvus works. You have the proxy as the stateless gateway, and then you have a fleet of query nodes that actually hold the data segments and run the searches. Historically, the proxy would do some basic parsing and then farm the query plan out to the relevant query nodes. Each query node then had to do its own optimization on its local piece of the puzzle.
Which means you have duplicated work and no global context. Each query node is in its own little world.
Exactly. By moving a lot of that optimization logic up to the proxy, you centralize it. The proxy can look at the entire query, understand all the filters and vector searches involved, and create a much more efficient, globally optimized execution plan before it ever hits the query nodes. The query nodes now receive a much simpler, pre-optimized set of instructions.
So you're trading a bit more CPU and memory on the proxy for less coordination overhead and way faster, dumber execution on the query nodes. This completely changes the dynamic. You might need to beef up your proxy deployment, but you can potentially get more throughput from your existing query node cluster.
That's the trade-off. It makes the proxy a more critical, state-aware component, but the overall system performance should be much better, especially for complex queries that span many segments or partitions. It reduces the chatter and redundant computation across the cluster. It's a classic move towards a more sophisticated coordinator.
Speaking of performance, they mention optimizing the like operator using STL sort. That's such a specific, low-level detail to include.
I love seeing things like this. It shows they're really down in the weeds. The like operator, especially with wildcards at the beginning like %substring, is notoriously hard to optimize. Using a standard library sort function suggests they've found a more algorithmically efficient way to handle the filtering of scalar fields. It's probably moving from a linear scan in some cases to something closer to n log n complexity, which for large datasets is a game changer.
So if you're building an app that lets users filter products by name while also doing a vector search on the image, that name filter just got a lot faster.
Right, and it's not just that. They enabled concurrent execution of text index tasks for multiple fields. Before, if you had a collection with, say, a title field and a description field, and you wanted to build an inverted index on both, it might have been a serial process.
blocking the whole indexing pipeline.
Yeah. Now Milvus can kick off those index tasks in parallel. If you're running on a multi-core machine, this drastically cuts down your indexing time after a big data import. For anyone with a CI/CD pipeline that re-indexes data nightly, this change alone could shave a significant amount of time off their batch jobs.
Okay, so the theme is faster, smarter. But then there's this whole other category of changes that feels like it was written by an SRE team that's been through some battles. I'm looking at things like supported pausing GC at the collection level.
Yes, this is about giving operators more control. Garbage collection in Milvus is what cleans up deleted data segments. It's crucial for reclaiming disk space. But what if you're in the middle of a massive data backfill or a delicate migration? The last thing you want is an automated GC process kicking in and competing for I/O resources, or removing segments you might need for a rollback.
So this is the big red hands-off button for a specific collection. An operator can now script it. Pause GC of my collection, run their massive update or migration script, validate everything, and then resume GC of my collection. It turns a potentially risky, unpredictable background process into a deterministic, controllable operation.
And it pairs with another feature here. Implemented a penalty policy for query nodes to handle resource exhaustion. This is straight out of the production hardening playbook.
What does that actually mean, a penalty policy? Is it throttling the node?
Think of it as adaptive load balancing. If a specific query node starts reporting high CPU, memory pressure, or maybe even just slow response times, the coordinator, probably the root coord or the proxy, can start penalizing it. This means it will be temporarily less likely to be assigned new segments to load or new queries to process.
So it's a soft quarantine. Instead of the node just falling over and a Kubernetes liveness probe killing the pod, causing a whole disruptive restart cycle, the system itself gracefully reduces the load on the struggling node, giving it time to recover.
It's a proactive, self-healing mechanism. Maybe the node is running a heavy compaction task in the background, or it just got hit with a few unusually expensive queries. This policy prevents a temporary spike from causing a cascading failure. It improves the overall stability of the cluster under unpredictable load. For anyone running Milvus at scale, this is a massive reliability win.
That makes a lot of sense. I'm also seeing a ton of little things that add up. A retry mechanism for object storage reads on rate limit errors. That's huge for anyone on AWS3 or GCS where you can get throttled.
Totally. It bakes resilience into the storage layer. Instead of your query failing because S3 momentarily pushed back, Milvus will just transparently retry a few times. They also added a fallback for object stores that don't support conditional writes, which improves compatibility with a wider range of S3-compatible storage like MinIO.
And preventing unnecessary segment sealing when you just alter collection properties, that's a quality of life improvement. Previously, you'd change a simple TTL property and suddenly trigger a cascade of data sealing and indexing operations.
It was super inefficient. It's like repainting the whole house because you wanted to change a light switch. This change makes metadata operations much cheaper and less disruptive.
There are a truly staggering number of bug fixes in this release, over 40 of them. It seems like they went on a major stability and correctness crusade.
And the nature of the bugs tells a story. Fixed RBAC etcd prefix matching to prevent potential data leakage. That's a critical security fix. Fixed etcd RPC size limit exceeded error when dropping collections. That's a scale problem. Someone tried to drop a collection with so many segments that the metadata update blew past the default RPC limits for etcd.
So they're clearly seeing users push the boundaries of scale. And this one, fixed race condition in storage initialization. That's the kind of bug that's an absolute nightmare to debug in production. It shows up once in a blue moon and causes chaos.
Right, and fixing it demonstrates a real commitment to hardening the core. Another one is unified read-only node handling to avoid stuck balance channel tasks. This suggests they're improving how Milvus handles heterogeneous clusters, or nodes that might be temporarily taken out of the write path for maintenance. It's all about making the distributed system more robust and predictable.
So if I'm a developer running a moderate-sized RAG application on Kubernetes using LangChain or Llama Index with Milvus as my vector store, what does 2.6.8 actually mean for me? Walk me through the practical impact.
Okay, First, the most visible change. Your user interface gets a new superpower. You can now call the Search API with a parameter to enable highlighting. You get back the text chunks and metadata telling you which words to bold or highlight. Your RAG app can now visually explain to the user why it retrieved a specific document. It's a direct upgrade to the user experience.
And I don't need to implement that logic myself in my Python backend. I just flip a switch in the SDK call.
Exactly. Second, your application will just feel faster and more reliable, especially under load. The query optimization at the proxy, the faster like operator, the concurrent indexing.
Okay, so the advice is definitely upgrade, but validate it first. The fixes for data security, storage handling, and concurrency alone seem to make it a mandatory update for anyone in production.
Absolutely. You're getting a more performant, more stable, more observable, and more secure system. And you get a new user-facing feature with the highlighter to boot. It's one of those releases that doesn't add a ton of brand new functionality, but it deeply refines and hardens what's already there.
And they even improved the SDK situation. I see the main server is 2.6.8, but the Python SDK is 2.6.6, and Node.js is 2.6.9. It's a bit of a maze, but it shows active development across the whole ecosystem.
That's pretty typical for a project this size. The different SDKs move at their own pace. The key is that the release notes give you the recommended compatible versions. So when you're updating your application's requirements.txt or package.json, you know exactly which version to pin.
So it seems my initial take was wrong. This isn't just a minor patch. It feels more like a production readiness release. It's Milvus growing up.
That's the perfect way to put it. This is the release that makes the system more robust for the enterprise. The flashy AI features get all the hype, but this is the hard, unglamorous engineering work that's required to actually run those features reliably at scale. This update is all about letting engineers sleep better at night.
That's AI Daily for today. If this helped you stay current, share it with someone who needs to keep up. See you tomorrow.